when we talk about technical interviews, and I'm going to define technical interviews specifically within the context of data structures and algorithm style interviews. So that's what the DSNA stand for. These are the kind of interviews that you're likely to encounter at a top tech company like a Google or Facebook. Um, who knows what Twitter's doing nowadays because they wilding. But those big tech company, Amazon. The key to nailing technical interviews of that nature really is brainstorming. That's the key. If I could sum up good interview technique and performance in one word, it would be brainstorming. And to do brainstorming effectively, you need two things. One, you need to understand the problem that you're trying to solve. And then you need to know your tools so that you can bring the right solution to the right problems. Okay. That's what brainstorming is all about. Understand the problem really well, understand your tools. If you know your tools really well, but you don't understand the problem, doesn't matter what solution you come up with, it's not going to work and fit the problem. If you understand the problem, but you don't know your tools, you're still not going to be able to come up with a solution. So hopefully you see how those two things work together. Many people, when they study when they study for technical interviewing, spend all their time on LeetCode, learning algorithms and data structures, and that's great. That you need that to know your tools. But if you don't work on understanding the problem and asking good questions, you're still not doing yourself justice. So we're going to talk about understanding the problem, but then also to a lesser extent, what it means to know your tools and succeed in technical interviews. Now, there's two things we're going to talk about. One is handling coding interviews, just generally and specifically. And then we're going to talk about handling behavioral interviews, because sometimes behavioral interviews do have technical components to them, even though it's not strictly technical. So I'll just give you a little bit of advice on how to handle that with the time that we have. All right, so let's talk about coding interviews. There are a few different kinds of interviews that, before we do that, two questions you need to answer when it comes to succeeding in a technical interview. Number one, can you reach an optimal solution with minimal supervision given enough time? So many technical interviews are going to be about 45 minutes to an hour. If you're doing the classic like whiteboard style or the coding interview, many times it's about reaching an optimal solution with minimal supervision given enough time. So can you show me that you're moving in the direction of something that's actually optimal, that is the best? Okay. Can you move in that direction? You may not actually get there, but can you move in that direction with minimal supervision? So am I holding your hand, having to tell you everything to do, or am I just giving you little hints and little prompts that then you're able to take and run with? Right? Can you do that if I gave you enough time? So 45 minutes isn't really enough time. An hour isn't really enough time. But by the time that 45 minutes or an hour is over, would you convince me that if I left the room, that you'd be able to keep going and get to that optimal solution? That's the question. That's one question that you need to answer for me. The second question that you need to answer, and this is very important, what do you do when you get stuck? Okay, because your job doesn't really get hard until you get into that situation where you're facing a problem that you don't clearly know how to solve and for which there's no clear solution. You can't just go to Stack Overflow or Google it. When you get into that situation, what do you do to get unstuck and to move forward? So those are two very important questions that we need to answer. Can you reach the optimal solution with minimal supervision given enough time? And what do you do when you get stuck? If you can answer those two questions well, you're going to succeed at most, if not all, of your technical interviews. Okay. Now, when we talk about technical interviews, there are different flavors and varieties. I know that I said that I want to focus primarily on data structure and algorithm interviews, but let's also talk about knowledge-based interviews. These are the kinds of interviews that take the form of quizzes, right? You can take a knowledge-based interview right now on a bunch of different technologies on LinkedIn. You can go on the platform, take some quizzes, get some little stamps on your LinkedIn profile to show that you know basic things around web dev, front end, back end, whatever. Okay. So those are knowledge-based quizzes. They're typically the easiest because you can study in advance and then knock that out of the park. The next is the behavioral interview. I talked about that a little bit. Even though behavioral interviews aren't primarily technical, they may contain some technical stuff. So they may ask you how you would implement some kind of a technical solution given some theoretical problem, okay, or how you might communicate with other teams to make that happen. So know about the behavioral interview, you're probably going to get it. Then there's the coding and pair programming interview. Many times they involve data structures and algorithms, but they don't have to. You can have a coding or pair programming algorithm that has nothing to do with algorithms and data structures, and is more just about helping you to make changes in some code base to prove that you know how to do it. Okay. There's the take-home project. This is the kind of thing where you've got an exercise that you work on. You work on it on your own in the comfort of your home, wherever you want to do it. It could be 5 hours, it could be 5 days. It all depends on the project. But the benefit of this is that it allows you to exercise and show your practical skills by building something real or realistic using whatever you want. So that's what the take-home project is about. Gives a lot of signal. Sometimes you have to do an interview after that just to defend why you did things a certain way and explain how you put it all together. But a lot of folks like the take-home project. And then there's the design interview. 2 kinds of design interviews. There's the system design interview that will ask you to build some large-scale system. And then there's a smaller design interview that's like, can you build a class that does these specific things? That solves some general problem. So whether you're junior in your career or whether you're senior, you're probably going to face a design interview of some kind. So you should be ready for that. Okay. A couple of things that we're looking for when in any solution that you implement. So first of all, are the solutions that you build correct? Do they meet the requirements? If I tell you that I need some code that does this, this, and this, did you build something that meets all 3 of those checkboxes? Or did you only fulfill 2 of the requirements? Or did you ignore them at all? I'm also concerned about if you met all the requirements and then added your own, right? That's still not quite correctness. That's not a strict adherence to the requirements. And so understanding, again, the problem and the nature of the solution is important so that you can build solutions that are correct. Collaboration. Do you know how to talk to other people? Do you know how to have a conversation with other smart people about technical things and not confuse them or yourself? Okay. So collaboration is about communication, whether that be verbal, written, etc. Even body language is important. But then do you know how to receive feedback? So when someone says, I think that there's something wrong with X that you did, do you get defensive and want to fight? Or do you say, oh, okay, well, let's take a look at that. Let's look at the data and make sure that makes sense. Okay. So yeah, collaboration is important. Syntax and style. So there are a lot of bad coders out there that know how to code, but their code is unreadable, not very well understood. It may have inconsistent style. You may suffer from bad syntax. There are people who depend on the IDE to do everything, but if you take that away from them, they don't really know what they're doing. Or even worse, they just copy paste from Stack Overflow. Nothing wrong with Stack Overflow. I love Stack Overflow, but if you are the person who exclusively copies and pastes from Stack Overflow to get your work done, that's not good. You need to be able to write code fluently and well using the right syntax and style. Because remember, if you're trying to get a job at one of the big tech companies, they don't mess around. They've got time to wait for the best of the best. And so you want to make sure that you demonstrate that well in how you write code and develop solutions of any kind. Performance is important because when you're writing stuff for millions of people or billions of devices, performance matters a lot. Your stuff cannot be slow. You cannot be the reason why, like, it takes 2 minutes to render a web page or something, right? Or why it takes 3 days to process some data that folks really need. So coding for performance is important because the kind of stuff that you develop for a couple of hundred people is not the same kind of stuff that you can use for 3 million people. That's not how code and systems work. So you need to be performance minded and you need to demonstrate that you care about that. And then last but not least is design. Can you map design to a solution in such a way that it's not overly complex? Okay. So that's what we mean by design. Design really is about managing complexity. There's a necessary amount of complexity, and then there's everything over that. Okay. So again, I'm going to mention gold plating because I often talk about that, and I see that sometimes is a problem. People will design for everything in the kitchen sink instead of thinking about, okay, what's the bare minimum that I need to solve the problem well? Okay. So in design is something that you learn with more experience. Okay. So, many times when you're doing technical interviews, you're not just doing one, but several. Okay. I know all of us would like to go in, do one 45-minute interview or 1 hour interview, and then decide whether we get the job or not. I know that we would love that, but the problem is that it's possible to game one interview or to really knock out of the park and get lucky on one interview. It's really hard to do that 5 times. So that's why companies have you go through the interview loop, right? Or sometimes it's called the on-sites, where you talk to 4 or 5 engineers doing 4 or 5 different kinds of problems. And what people who are looking at your feedback are going to do is they're going to look to see if you have consistent signals. So are you a great problem solver when the problem suits you, or are you a good problem solver no matter what the problem is? Do you communicate well when you understand what's going on, but then you get super quiet when you don't know what's going on, right? Those are the kinds, those signals matter. And so you can knock it out of the park on one interview. And if you do horribly on the other 3 or 4, that's not going to bode well for you. Same thing, if you're super average on everything, right? Like you're just barely passing on everything, that's going to send a certain kind of signal. But if you do well on 2, you do okay maybe on 2, you really knock that 3rd one out of the park, that might be enough. It depends, right? So, but it's all about those signals, right? And so you want to make sure that you demonstrate the right qualities consistently, which is why I wrote an article about 6 things that I think that you need to do to be successful in technical interviews. And so this 6-step problem solving framework that I've proposed is designed to help you be more consistent across your interviews by suggesting that you do 6 things in a specific order in order to maximize your performance. Here are the 6 things. Number 1, I want you to just repeat the question. So when you get into a technical interview, there's going to be some problem that your interviewer is going to tell you need to solve. The very first thing that you should start out doing is just repeating the question that they asked you. It may sound super simple, but it's harder than you think. Because number 1, you've got to be listening really well and making sure that you're getting beyond any communication issues. 2, you've got to chew on that a little bit and understand like what all that really means so that you can repeat it back accurately. And then, if there's something that you didn't say, your interviewer can catch you and say, hey, I don't forget that you need to do this specific thing. Or if you said something that the interviewer didn't say, they can say, wait, hold up. You don't need to do all that. Just do this other thing that I asked you to do. So it just helps you to iron out that communication and make sure that you're on the same page with your interviewer. Buys you some time to think as well, right? And so instead of looking at your interviewer silly and quiet, right, you can just repeat the question back to them, and that still allows you to think about what you need to do and begin processing information. Some of you are really good about asking questions, and in the middle of you asking questions, you answer them yourself. That's called rubber duck debugging, right? Where you are expressing a problem out loud and in the sound of your own voice. And sometimes just doing that much will help you think about it a little bit differently. So just repeat the question because it's a good idea, something that you want to do. Another thing you want to do is ask clarifying questions. Okay. So once you have heard the question, there are things that you need to ask. Even if I think I understand the problem perfectly, I'm going to ask at least 3 questions. Like always. I always got 3 questions I can ask. Does the input fit in memory? What's the type of the input? Do I need to worry about edge cases? Or at least 3 questions I can ask for any technical interview situation. Okay. And there's going to be more that you're going to ask. Why? There's 2 things you're going to do. Number 1, you're trying to understand the problem more, but then also the other thing you're trying to do with your questions is figure out which of the solutions can I use. So there's some algorithms that I can use in some situations, right? Like I can use binary search right away if my input is sorted, right? If my input ain't sorted, I can't just use binary search. Okay, I got to do something else first, and then I can use binary search, right? If it's even the kind of problem where I need to use binary search. So I'm going to ask questions to figure out, okay, do I need a sorting algorithm? Do I need a searching algorithm? Is there just a data structure that I need to work with? Let me figure out what I can take off the table by asking the right questions. Okay. So that's what asking clarifying questions is all about. Third thing you're going to do is use examples, right? So, all right. So if I have these inputs, you want me to turn these inputs into those outputs, right? You need to do that. So if they ask you to sort an array, come up with an example array that has some real data in it, and then come up with an output. One of the things that I love about using examples is if you don't come up with the right example, your interviewer has to tell you, Oh yeah, look, you have duplicates in your input, but in the problem, you're not actually going to get duplicates. Oh, good to know. I didn't even think to ask about that. So coming up with examples um, ensures that you're still on the same page with the interviewer, but also can force your interviewer to give you more information that maybe you didn't even think to ask about in the clarifying questions. So using examples is powerful. Another way to think about it is come up with test cases. Okay, so um, if you don't study stuff like how to come up with good test cases, again, you're not preparing as well as you should. Think about how to come up with good test cases, how to think about border conditions, and then come up with 2 or 3 examples. It is really harder than it sounds, which is why you need to practice it. Okay. Number 4, brainstorm your solution. So between steps 1 through 3, you have enough information to get to work. Now, step 4 is just about taking all that algorithm data structure stuff that you were studying, all the coding tools and libraries and connections and APIs, start to put that all together to come up with a solution. Now, by this time, you're probably going to have one obvious solution, the brute force solution. The naive solution is another name for it. You're going to have that one thing that just comes to mind that you're going to be ready to rock with. That's all good. What I'm saying is stop and try to think about 1 or 2 ways that you can make it better. Okay. One question I'll always ask is what's the absolute best I can do? And what's the absolute best I can do? I often use the example of wedding planning for folks who are non-technical. If you are a wedding planning, what's the cheapest you can get a wedding done for? In my mind, the optimal solution, like the really, really optimal, if we're talking about money, is somebody pays me to get married. Okay. That's what I want, somebody to pay me. See, I want to actually make money from this endeavor. Okay. That's the absolute best I can do. It might be really hard to get that kind of outcome, but because I know that it opens up doors of opportunity that maybe I didn't think of. Or how can I sell this as a thing that somebody might be willing to pay for? Do I need to get on TV, something like that? A lot of people don't think about that, right? Or they don't really give that consideration. But when you when you think about the optimal, the best solution, like what that theoretical best is, it helps you to think about, okay, well, what are the tools that might help me to do that? Okay. So brainstorm solutions. Don't just think up one, think of multiple if you can. All right, 5th thing that you need to do, obviously, is implement it. In these coding interviews, in these technical interviews that they have us doing out here nowadays, you actually got to write code in front of somebody to even get the job, right? So you can't be pretending, and it's not pseudocode. It's got to be real Java, JavaScript, C++, C Sharp, Rust, whatever it is that you're working with. You got to code in real code. A lot of people like to use Python. That's great. You can do some sneaky syntax sugar kind of stuff with Python, but you better understand what's happening underneath the covers. That, like, just because you can write it all fast in Python doesn't mean that it's actually making your stuff run faster from a big O time and space complexity. So just know your tools, know your language, know what you're working with. And even if you're not a coder, if you're a hardware person, know that. If you're a UX person, know the tools that you have at your disposal. If you're a project manager, product manager, I guess you better know, that spreadsheet software real good. But whatever your tools are, you need to talk about how you would implement that in a concrete way and make that good. And remember, pay attention to syntax and style, which is why I always say, don't practice with an IDE. Practice with pen and paper, practice with a whiteboard, practice with a word processor, then copy the stuff that you built, put it into a real tool, see if it all passes the checks. Okay. That's all that. Then step 6, test. Test yourself before you wreck yourself. Always check your work. Always check your work. Why not? Nobody gets it right the first time. And you're not expected to get it right the first time in the interview. You're going to make mistakes. Just check yourself. Don't make me have to point out the bugs to you, because I will consider that holding your hand. Okay. Take the initiative to test your work, check yourself, and then make sure that it's all good. Okay. So those are the 6 steps that I propose if you want to be successful in navigating technical interviews. Do this every interview. You will show the consistent signals that get you hired. Now, there's alternatives. Let's say you don't like my 6 steps. I'm all good with that. I ain't mad. There's Reacto. Reacto is very simple. Repeat the question, use examples, think about different approaches, write out the code, test your code, then optimize and make it better. Does all this sound familiar? Yes, the same stuff that I said in my 6 steps, just in a different order. So if you want to do this order and this jives with you, be my guest, do your thing. But the point is that you need to have your own process and work through that. Let's take a look at an example question just to kind of put this all together. So given an array of numbers and a target value, I want you to return two indices of return the indices of two numbers in the array such that they add up to the target. All right, I'm gonna give you 2 seconds to read this, and then I want somebody to type out the problem statement right now. Okay, what's the problem that we need to solve? Somebody type it out. I'm gonna wait for a couple of you to do it, because I bet you didn't think this was gonna be interactive, huh? All right, what do you think? Yeah. Woo! Yeah, that's right. Putting you on the spot. Right, giving an array of indices and two values. I forgot the rest. Yeah, yeah. Yep. I understand. No, that you getting there, but not quite. Anybody else want to give it a shot? Find two numbers in an array that add up to the target number. Yeah, good job, Mark. That's it. Give an array of numbers. I'll put two indices that add up to the target. There you go. Yep, you got it. You got it. So, yeah, absolutely that. What you just did in the chat is exactly what I want you to do when you're repeating the question, right? I want you to soak up this information, listen, pay attention, right? And then be able to spit that back to me, because that will make sure that now, if you, let's say that you didn't get things right, that's okay. I got you. I, as your interviewer, going to say, oh, no, I don't need, there's not going to be two target values. There's just going to be one, or you're not just going to return one index, you're going to return both of them. Okay. So that's the deal. Now, here's some questions that you can ask. The numbers, are they integers? Are they floats? Are they decimal? Right? What are they? Can they be negative? Does that matter? Okay, those are some good questions that you can ask. Is there a minimum or maximum length of the numbers? Do the numbers, are they, signed 32-bit integers? Are they unsigned? Are they 64-bit? Are they shorts? Are they, ints, but they only go up to 1,000? Are they telephone numbers? Right? There might be some pattern to the numbers themselves that gives you some advantage. Are they sorted? Okay, is another question that you could ask. Will there always be a solution? Is it possible that we'll get into a situation where you give me some input that I can't process? This is a good question, right? And a lot of people don't think about that. You may always assume that there's going to be a solution, but maybe there's times where you just need to throw an error because, like, the fives will never occur in the input. And if you get a 5, you should throw an exception because somebody did something stupid. Okay. So there's that. And then, yeah, I think there's a great question here. Will there be more than one possible solution? Yeah. Is it possible that we're going to have a range of valid things and I just need to return the first one or the last one or whatever, the most common one? Great questions. Here are some examples, right? I always say if your interviewer gives you some examples, use theirs and then maybe add one more. If they don't give you examples, you come up with them. Okay. Don't rely on your interview to do that work, your interviewer to do that work for you. If they're not giving you examples, you come up with your own. Okay. So if I have the sample array where I've got two values that need to add up to 9, then my output could be 1 and 2, index 1 and 2. So at index 1 and 2 in this array, I've got the values 1 and 8, 1 and 8 add up to 9. We're good to go. If I need to add up to, I have another array where it's two numbers that need to add up to 15. And so for this, I have the values at index 1 and index 5. So remember, I'm returning the indices, not the actual values themselves. If you return 8 and 7 for the second example, you will have a wrong solution because that's not what we're looking for. We're looking for the indices. Okay. So this is really important. All right. Now you want to brainstorm, right? So you've repeated the question, you've asked some follow-up questions, you've worked through some examples. Here's my brainstorming. I'm like, okay, I can do this in 2 loops because I've done enough problems to know that I can use 2 loops for this. I know that's big of n squared time because 2 loops, and I don't need any additional space. I can use a data structure to find the complements. That would be linear time. And here's the thing, it's not constant space, it's actually linear space. So I messed up on the slide. I'll fix that later. But and how do I know that it's linear space? Because I need to use a data structure, and most data structures require linear space, big O of n. So not only am I saying here are the solutions, but here's how I measure the performance of that. If I'm looking at UX, maybe I'm measuring the number of clicks or the amount of time that it takes to complete a task, and I'm going to use that to optimize. But however I'm measuring the benefits of one versus the other, I need to talk about that, right? In all the trade-offs. So, do we want to optimize for speed? Do we want to optimize for space? Figure that out. Okay, but that's what Big O is all about. And ain't that hard if you give it some time to study. All right. Like I said, we could use Reacto to do all of this stuff if that's what you prefer. But I got my 6-step because they're mine. So, all right. We're totally going to skip handling behavior interviews because I'm out of time. The cheat code is use star situation, task, action, and result. That's the key. You've probably heard this 1,000 times. The one thing that I'll say is when you are using star, practice beforehand. If you come into an interview with me talking about, all right, situation, the situation was this. Okay. And then the task I needed to was this, right? If you come at me like that, I'm going to be really annoyed as your interviewer. Instead, you should practice star beforehand, know kind of how you're going to articulate your stories and come natural with it. So I don't feel like you're pretending you're lying to me. Okay. Another thing that you should think about with your behavioral interviews, the data should come from your resume. So look at your resume, study your resume, make sure that you understand the different elements here, and be prepared to use your resume to answer questions about behavioral stuff. Okay. Because all of this is the evidence. So I'm like, oh yeah, I remember a time where I did XYZ and we were able to get, 90% penetration of Google's workforce every month. Like, boom. Okay. So you want to be able to do that. You probably won't have your resume in front of you so that you can, read off of it. Maybe you will. I don't know. But the point is that you want to use your resume for that data and for that stuff so that you can say, this is what I have done to be successful. And because I have done it before, I know I can do it for you. Let's skip the dragon. All right, here we go. Thank you. Don't go to that link. I don't know why it's like that, but at this point, we're going to move on to the questions. Follow me, Anthony D. Mays, on all the things. I especially like Twitter. I'm particularly active there, at least while it's alive, until it burns up and dies. So I'll be there, but also on LinkedIn as well. Feel free to reach me there or visit anthonydmays.com, where I've got tons of articles, including the articles on the 6 steps, how to leak code effectively, how to do technical interviews, how to do behavioral interviews, all that stuff. All right, let's get to the questions. What 2 algos should I study and practice that could basically stretch across interviews, which are the most broad, so to speak? That's a great question. So I'll give you, the short answer is bigocheatsheet.com, which has more than 2, obviously. I do recommend that folks learn a couple of sorting algorithms. So merge sort and quick sort are my favorites. There are others too. I think that helps. You should know binary search. So like binary search and quick sort at the very least are 2 algorithms that you should just know. Of course, if you're going to want to be successful, you're going to need to learn more than that. So, there really aren't a lot of cheat codes. You got to put in the time, you got to put in the work. That's just how it is. For data structures, know how to use a map, know how to use graphs. If I had to pick only 2, know how to use a hash map, know how to use graphs. If you know how to use a hash map, you're dangerous because many problems are solved optimally using a hash map. So know that. And then if you think in terms of graphs, that will help you a lot because many problems are naturally represented as graphs. So, think about Google Maps, graph problem, Chess AI, graph problem. A lot of stuff is represented as a graph problem. And anytime you're thinking about things like recursion, you're basically doing DFS, right? So that's what I think. I know I gave you more than 2, but sorry. It is what it is. All right, cool. Thank you for the question, Isaiah. Genesis asked this: beyond data structures and algorithms, what are your best tips for API structure related questions? That's a fantastic question. So when it comes to APIs, I think it's important to understand. So first you want to understand like what the styles are. So depending upon different contexts, there are different styles of API design. So you might think more broadly to service-oriented architecture and how APIs fit into that. You might think of RESTful APIs. You might think of GraphQL style APIs and what that means and how that all works. Understand the trade-offs and advantages or disadvantages of one approach versus another. You want to think about how do you assess whether you pick one versus the other? Who are your clients? What languages are they going to rely on? What kind of qualities do you need in the API? API building good APIs. There are design principles that help you. And I have a really good book on APIs. So Microsoft Press came out with a book about the .NET framework patterns, and that was a great book on coding APIs. Because they talk about decisions that they made to build out the .NET library and some of the patterns that you see there. So that was a really good book. It's old, but I think it's still useful. And then, all that stuff. Looking at example APIs and studying why they're designed the way that they are, that's something that's useful. So pick your favorite API and think through. So like, for instance, I worked with the Google APIs for a long time, obviously. Looking at Gappy, how do they decide on the methods that they use? What are the patterns across different API endpoints that they have? That's good. APIs are such a big area for sure. So I'm just kind of coming off the dome piece with things that I think are useful to help you make that more clear. But I think one of the things that really helps you with designing good APIs is experience. And so many of you, one of the things I wanted to tell y'all is that interview prep starts with the job you have today. Okay, it starts with the job you have today. So wherever you are working right now, you should start your interview prep by doing the things that you should be doing to be effective as an engineer or as an architect or as a tech lead, et cetera. So do those things on the job you have today. And as you do those things, it'll make it much easier for you to do that naturally in an interview. Okay. So just like you would think about, okay, what's a good API for something that I would do at work? Think more broadly about how you would abstract that to a potential interview question or to a different kind of problem set. So hopefully that helps and gives you enough detail. Susie, should you always start with the brute force solution and optimize even if you know the optimal solution off the top of your head? It depends. So if you've heard a question before, if you've heard an interview question before, you should absolutely let your interviewer know, hey, I've done a problem that's like this or that's very similar. Here's the different ways that you can solve it. Here's the optimal solution. Would you like me to code with the optimal solution? Okay. Because your interviewer may say, oh, dag, you heard it before. All right, let me go find a different question for you. Or they may say, yeah, let me just see you do the optimal solution. Then we can talk about something different. I always say, just ask your interviewer, right? More likely than not, when I'm interviewing folks, I want them to do the brute force solution because some people get it in their head that they're the business and then they start trying to do the optimal solution that they don't really understand. And then they get really stuck and I still don't have code from them. And so if you can get through the naive solution, you may not even need to implement the optimal solution because I already know that you know how to code and put things together. So more often than not, start with the optimal solution. That way you get points on the board quickly and then work on the more optimal thing. Okay. That's usually what I recommend. But if you're in doubt, if you really feel confident that you can get to the optimal solution, express that to your interviewer and go. At the end of the day, you're in control. So you can do what you want to do. You're a grown person. But like I said, I think that I would prefer that you ask your interviewer, hey, I think I know the optimal solution. Can I go with that? Or would you rather me go with the brute force solution? Again, more often than not, I want people to do the brute force solution. And, I've seen people who are really smart and good at technical interviews who will just agonize and skip what they obviously know is the naive solution, but because they think it's too simple, they won't actually do that. And they've actually lost time on the clock. And so I had to tell them like, hey, what if you just do the simple thing? And be like, oh yeah, I could do that. And then they knock that out. Don't be that person. Okay. Don't be afraid to do the naive solution. Get that code on the board, get those points on the board, and then make it better later. Because if you can implement the naive solution really well, we might just have a discussion about the optimal solution, and that's that. All right, another question. Is there a DSNA course that you could recommend? Do you recommend just foraging through Google for free resources? Yeah, so a couple of things. I relied on books, so Cracking the Coding Interview was my go-to jam. I still use Cracking the Coding Interview, but I also have, what's this other one? Not this one. Shoot. Hold up. So Cracking the Coding Interview, super useful. Y'all should have that book if you don't already. And then Programming Interviews Exposed is another favorite one of mine. Here's what it looks like. So this one is much more about the data structure algorithms knowledge. So if you don't really know a lot, start with this one. This one has the sample questions. So, and then each chapter expounds on strategies that you should use there. And then if you're preparing for design interviews, because you've got like more than 5 years of experience, designing data-driven applications is definitely for you. And even if you're a junior, read this anyway, because it's dope. Okay. So those are a couple of books that I would rely on. I don't like paying a lot of money for sure. And so I did a lot of foraging and putting stuff together, but I also had a CS degree. And so I had 5 years of a formal computer science education. If you didn't have that, you might invest in the course, because even if it's like, $2,000, $3,000, that's a lot less than the tens of thousands of dollars that I spent for a 4-year degree to get, only to fail algorithms class twice and then succeed on the third time. So I'm definitely a fan of using and taking advantage of free resources. There are plenty out there. There's geeksforgeeks.org, which I love. I'm a fan of that website for sure. You can use LeetCode for practice questions. But if you really need somebody talking to your face, helping you out, then maybe doing a course is the way to go. What sparked my passion for teaching others about technical interviews? Passing the Google interview. I tried the Google interview in 2011 and failed. That was like that was 11 years into my career professionally. I was very disappointed and dejected by that, but it was because I didn't have the right information. When I succeeded in 2013 is because I had the right information and paired that with the hard work. A lot of you know how to work hard, or you're willing to work hard, but you don't have the right information. I want to help you have the right information, because really, I was very happy in my career before I got to Google, and passing the Google interview just put everything on a whole nother level. And I want to see other people have that kind of success if you're willing to work hard, because certainly it's opened a lot of doors for me personally, professionally, and financially. So that's why I'm passionate about this, because really everything meets at the interview. Everything meets at the interview. Opportunity, network, all that stuff. You get past that, and that can open up a lot of doors for you. Okay, but you got to get that part. Seriously, how long should we study on a new language if needed? And are there some companies in new product tech purgatory that are always changing? Yeah. Here's the thing. I think you study programming languages and stuff for yourself. I think that's what you want. Study programming languages to understand how they work and to satisfy your own intellectual curiosity. Get experience with that language and then go with it, right? It doesn't take that. So funny story. I thought that the Google interviewers are going to be racist, and so I was trying to be prepared. I was trying to be way over prepared, and so I didn't interview in the language that was native to me, that is C#, the one that I was doing all day. I wanted to program in Java to look as much like what I thought a Google engineer would be using as possible. So I studied that for a month and a half. I used Java in college, but I really want to be good for the interview. So I did all my practice problems and program exercises in Java. And after a month and a half, I was able to answer all the questions I needed and pass the interview. So, you could use that as maybe a benchmark. But the point is that pick something, use it every day, really figure out how this stuff works. Read the documentation, all that stuff. That's generally how I would deal with that. And personally, I got a lot of benefit from working in a company that, I learned, I don't know, like 11 different programming languages at the first job I ever had because they had that same kind of thing where they just didn't know what to do. So they used everything. That was good for me because I got to pad my resume with a whole bunch of keywords and learn a lot of languages. But after you learn the first 2 or 3, everything else is it's just all the same after that. So go learn an object-oriented language, go learn a scripting language. And after that, do what you want to do. Okay, we're at time, and I'm so grateful to have been able to spend this time with you and to do all that. I don't stop with this, so please do, like I said, check in with me at Anthony D. Mays on all the things, including Twitter, LinkedIn. Visit anthonydmays.com. And one more thing. You can go get my business card at the link that I'm going to type in here, ml.tips. Sorry. amaze.me/links. I just released a newsletter and I'm going to start adding interview tip of the day there. And so you can sign up to get my business card or peep the newsletter and then get connected to even more resources, including the stuff that I included here. Thank you all for the great questions. Really appreciate you. And I hope that you enjoy the rest of the conference. Other than that, peace.